All right, so we're going to do our sine area formula today. A lot of people out there, they like to call this the side angle side formula for the area of a triangle. So instead of having to have the base and the height to find the area, what you can do is you can have two sides, so like A and B, and as long as you have two sides and an included angle, side, and an included angle, you're able to find the area. So I'm going to prove this real quick, and then we'll do a couple of examples. All right. So instead of the h right here, because that pesky h is so hard to find sometimes, I'm going to find h in terms of c here. Let me do sine of angle c. All right, so I've already got a right triangle built. All right, you kind of have to have a right angle when you're doing the area of a triangle either way. So sine of c, that's going to equal opposite over hypotenuse. So opposite is going to be h, and hypotenuse is going to be a. All right, take this little expression, and I'm going to solve for h. So if I multiply by a, the a's are going to cancel, and I'm going to get h is equal to a sine of c. That right there. All right, now I can just make a direct substitution over here. So instead of an h, I'm going to put a sine of c. So the area is going to be 1/2. It's going to be, I guess I'll write it, b times a sine of c. Now, normally they're going to write it where the a kind of goes first. So it's going to be 1/2 ab sine of c. And c is the angle that is in between a and b. This is going to be my formula. All right. I'm going to use that to find the area of some triangles. All right. So instead of having to know the base and the height, I just need two legs and the angle that comes in between them. And that's going to give me the area every time, no matter what kind of triangle I got, whether it's obtuse or whatever. So I've got this simple information. If you were trying to find the area of this using 1/2 base times height, you would be very, very stuck. Well, because if 7's your base, you don't know the height, right? If 4 was your base, you don't know the height, right? And so you get frustrated and stuck. But since we just learned this little trick, we're going to apply it. The area is going to equal 1/2. I'm going to multiply the two legs. So A and B are like my 4 and my 7. And C is the included angle. So times sine of 73. Okay. I could simplify this, I guess. 1/2 of 4 is equal to 2. 2 times 7, that's 14 times sine of 73. All right, this is where your calculator comes in. So 14 times sine of 73, and we're going to round it to 2 decimal places here. So I get 13.39. That's it. That would be my area, 13.39. I guess it would be like square units or units squared. So it's not too bad. Let's apply it for this parallelogram. So normally, if you want to find the area of a parallelogram, I think the formula is base times height, but I don't have this height right here. Okay. So what I'm going to do is I'm going to cut this parallelogram into two congruent triangles, and now I can use that formula. It was 1/2 ABC, AB, and then sine of an included angle. All right, so these are connected, and then this is the angle in between them. So I got 1/2 A times B. So that's going to be 24.6 times 15.8. And then the angle in between them is 123. Okay, 123. It's going to be sine of 123. Okay, this expression, I'll work this out. This is going to give me the area of this triangle. But then I'm going to have to double it to get my other one. All right. All right, so I guess I'll just include it here. So 0.5, that's my 1/2, times 24.6 times 15.8 times sine of 123. Nice. I get 162. Boy, that's big. But then I'm going to have to double that so that I get my full area. All right, for my full parallelogram. So times 2. That's it. 325. We'll just round it to the nearest unit. All right, these are big numbers. So the area would equal 326 square units. All right, that's it. We'll do some other stuff with it next.